Hello everyone. Today we want to discuss about the root locus system and we will see an example. So this is the extra note that I have shared with you. So it says that we need to consider on the following system, and we need to basically sketch its root locus. Okay, so from this system we can easily find its open loop transfer function. This is the one, open loop transfer function. Okay, open loop transfer function, which is gs equal hs, gs times hs equal k over s. This one you know, this one, this part. So from this open loop transfer function, we can also calculate the closed loop transfer function, or we can also find the characteristic equation. Okay, so if we want to find the characteristic equation here, so let's say if you want to find the CE, which we call it characteristic equation, equal 1 plus gs hs equal to 0. So we just simply replace the value of gs and hs here, then we can find the we can define the characteristic equation. Okay, so in order to solve this problem, we will show you step by step. Okay, so you see from this equation k over s into s plus a and s plus a, we can define the poles. In the last week I have shown you how to find the poles. So you can see for the poles, so we will look into the denominator. Okay, we'll look into the denominator. So in this case our s equals to 0 and s equals to minus 4 and s equals to minus 8. So that means we have total 3 poles. Okay, we have total 3 poles. So that's the reason we are mentioning n equals to 3. Okay, n is the number of poles. You can write here n equal number of poles. Okay, number of poles. If you want to see, if you want to check in the slide also, we can see that we discuss n actually is our number of poles here. You can see n we denote the number of poles. So same goes for the zeros. We can find the number of zeros. So which is m equals to 0, because there is no zeros here. You can see at the nominator part we do not have any s term, so that means we can say the number of zeros actually 0. So the difference between the poles and zeros, which is n minus m, it will be 3 minus 0, that means 3. Okay, so that is actually we find it here 3, because we need to find the zeros. Now in step 2 we need to find the number of branches. So how we can know the number of branches? If you you want to find the number of branches, so I will refer you this slide, and the slide number 31. You can see that if the number of poles is greater than number of zeros, that means n is greater than m, in that case what will happen? So number of branches will be the number of poles, that means the maximum one. So you need to take the maximum one. So you can see here the number of branches will be 3, because our n is 3 and m is 0, so that means number of branches will be 3. So now in the step 3, okay, here another thing we need to find. Another thing we need to find from the slide, which is the remaining branch, that means n minus 1, n minus m will start from poles and ends at infinity. So you can go here and you can see the number of locus that ends on infinity. Okay, that is the remaining one, right? The n minus m. So the remaining one that will start at poles and ends at infinity. So you understand, right? All right. Now we go to step 3. Step 3, we need to root locus on the real axis. Is just an initialization. You see, we have s equals to 0. This is s equals to 0. This is s equals to 4, and this is s equals to minus 8. Okay. This is our imaginary axis. This is our real axis. So what will be the direction of the pole? So how we can find the direction? So in order to find the direction, I refer you this slide. A number of branches done already. You done symmetry. Now this is done. The real axis segment. This is the one we are talking about. Okay. So if total number of real poles and real zeros to the right side of the test point is odd, then the point lies on the root locus. Anyway, I explain to you. See here, first we consider this pole. So if you consider this pole, the right part of the poles is actually at the right side of this s equal to 0 pole. We do not have any pole or 0, so that means 0. So 0 is an odd number, it's an even number, so the direction will be towards the left side. Okay. Then after that, if you look into this pole, which is s equals to minus 4, you see at your right side there is an odd number of poles there. Okay, if odd number of poles there, so our direction is this side. Okay. Then now you go to the next pole, which is s equals to minus 8. So if you see here at your right side, there are actually even number of poles. So the direction will not be here. So direction will be at the left. So it will goes to infinity. So this is the way actually we can find the direction. Then we go to step number 4. At the step number 4, we will find the asymptotes. How to find the asymptotes? To find the asymptotes, we have a formula. I refer to the slide again here. You see, in order to find the asymptotes, we need to find the real axis intercept, which we call it sigma a, and at the same time we need to find its angle, which is theta a. So in order to find the sigma a, the real axis intercept, so the formula is summation of finite number of poles minus summation of finite number of zeros divided by number of poles minus number of zeros. That's actually the formula. So we apply the formula here in this case. So you can see here the summation of finite and finite poles. So our poles are 0, minus 4 and minus 8. That the poles that we have got. You can see here again, I show you. You see, these are the poles we got, the 0, minus 4 and minus 8. So you take the summation of it. The summation of it will be 0, minus 4 and minus 8. Don't know why it is 0 here. We will no need to have 0. Here is the point. So and after that minus the summation of finite zeros. So but we do not have 0. You know that we do not have 0, so that's the reason is 0. So totally it will come minus divided by 3, because n minus m is 3, so it will be minus 4. So the intersection point is at the minus 4 on the real axis. You remember this one. Later we will see. Just we proceed for this moment. Then after that, the angles of the lines that intersects at minus 4. So we need to find the angles. So in order to find the angles, you see this is the formula, theta a 2k plus 1 pi. Guys, I don't want to use the k here because k might create you confusion. This k, remember, this is a gain. This k is a gain, capital K. This is a gain, this is gain. And this case they mention here like just a variable. Okay, this is just a variable, you can consider the x also, so it's up to you. But this k, this capital K and this k are different, they are not the same. That is the gain, and this is just a variable here. You can consider here maybe x. It's like that. So in order to find the angle, what you can do is it's just easy. So I write it for you here. Maybe this is sometimes it's confusing, plus minus, we do not need all this. So we have, let's say, theta equal to x, I mentioned as x, plus 1 pi divided by n minus m. It's like that. So now we have 3 poles. So if we have 3 poles, so that means our x will be 0, 1, 2. So the value of x will be 0, 1, 2 because we have 3 poles. So we want to know the angle at this because of the 3 poles. So we need to consider the 3 values, 0, 1 and 2. So let's say for theta 1, if we consider, so 2 times 0 plus 1 divided by n minus 1 is your 3, and this is your pi. Okay, so it will come 60 degree. It's like that, pi equals to 10. Okay, 180 degree. It's like that. So theta 2 also you can find same, like 180 degree. You can get theta 2. Theta 2 is 180 degree. For theta 2, you have to consider the value of x here is 2, and the next one is theta 3. Then you will get 300 degree. In order to find a theta 3, you have to replace the value of x here 3. It's like that. It's very simple. So we know the angle, and also we know the intersection point. Okay. Then number 5 is our determining the breakaway point. There are 2 points actually, breakaway points and break-in points, if you see. So let's discuss about the breakaway points first. If you remember the last class, I said there are 2 methods, differentiation and transition. We use differentiation. So in order to find the breakaway points, what I want to do, you consider the characteristic equation. Consider characteristic equation. Okay, what is our characteristic equation? Characteristic equation is, we know that 1 plus, I already told you, GS, HS, you know also, that one will be 0. Okay, characteristic equation. So if you replace the value of this 1 plus it will come GS, HS, what is that, is K over S plus 8, S plus 4, K over S plus 8, S plus 4. If you normalize it, then it will come K equal minus S cube plus 12S square plus 32S. Okay, it will come like this. If it's come like this, then we can find, now we need to find the differentiation of it. So dk over ds, the differentiation of k in respect of s. So if you find the dk, so it will come, actually dk equals 0, but never mind, I just put it here, 3s square plus 24s plus 32. That one has to be 0. Okay, in order to find the breakaway point, the differentiation of this term equals to 0. If you differentiate of this term equals to 0, then after that then you will get 3s square plus 24s plus 32 equals 0. So from there we can, this is a quadratic equation, you can find the value of 1.69, and not only that, sorry, minus 1.69, this is the one, the two values you will get, minus 1.69, and you will get another one, minus 6.31. So we will get 2 points. Okay, we get 2 points. So now which point, even though we have two breakaway points, but one point is valid. Why? You can see from this figure. Why? Because we have two breakaway points which we got 1 point minus 1.69 and another, I write like this, it will be easy for you to understand. S break 1, we got it minus 1.69, and another we got S break 2 equal come on, it's not clear, right? Break, B-R-E-A-K, just break, so equal minus 6.31. so you got these 2 points. So you see here, if minus 3.1, if the point will be here somewhere, but you see that there is no direction here, because the point cannot be exist in between these two. But we have another point which is minus 1.69, so that means point will be here in between minus 4 and 0. So that means this is the valid one. So this is the valid. Okay. This is invalid because it is between, S break equals to minus 6.31 is invalid. This is invalid. This is invalid because why? Because the point is between minus 8 and minus 4, because there cannot be any point between minus 4 and minus 8. Then we go to number 6, step number 6 here. So we need to find the j omega crossing. In order to find the j omega crossing, angular departure, this is not me, I think, never mind. So we need to, I think the slide is not there, but we need to find it, because when we will draw it, then we need this value. So in order to find the j omega crossing, I think it is there. Yeah, it is here, j omega crossing. Yes. So in order to find j omega crossing, we need to calculate the routes in the Hertz-Width table. The route table is very easy. So for this we consider the characteristic equation. Okay, this one is already characteristic equation, you have seen it from here. Okay, this is the one, is the same thing actually, characteristic equation, which is this line and this line, same characteristic equation. Then you create the route table. Okay, when this is the coefficient of s cube 1, s square 12, and s is 32, then after that k. Okay, this is the k. This k actually capital K. That's why it's confusing sometimes. I say because it's a game. Then after that, you know how to calculate all this position. Okay, so once you calculate, you know that in order to be a stable system, for stability, you know that for stability, what we have to do for stability, we have to, this part has to be, there shouldn't be any sign change on the first column. So since this is a positive, this one also has to be positive, this one also has to be positive. So if this one has to be positive, so that means 12 times 32 minus k is greater than 0, so that means k is less than 32, less than 384, and we have another one which is here, that has to be k is greater than 0. So our values is between actually this 0 and 384, the gain. So in order to find the marginal stable, okay, so our marginal will be here 384. So that's the reason we are writing 384 is our marginal value. Okay. So now we need to find the value of s. I mean, at the marginal value, you need to find the coordinates on the j-axis. Okay. So how we can find that is very easy. You just consider this one, the second order equation of this one, auxiliary equation as a second order equation. So if you find the auxiliary equation, so from here it will be 12s square plus k equals 0. So 12s square plus k equals 0. Then you can find s square equal to this, then s equal, because it's a negative, right, so it will be plus minus j 5.66. so this is actually the crossings on the j omega axis for k equals to 384. Now let's draw the, I think I'm done. Yes, done. So now let's draw the root locus. Okay, we can sketch it. This is I can show you here. In order to draw. We draw this. It's too thick, right? Change to this, see how. Okay, then another one is here. Okay, now now if we want to find our root locus, which is here, s equals to 0, right, and we have s equal minus 4, maybe here. By the way, this is, you already know, right, j omega, imaginary axis. This is your real axis, which you call sigma. This one actually we need to make it more. We can make it. Sorry. Okay. Then here you can get s equal maybe minus 8. Okay, this is j omega. Can understand clearly, I think. This is j omega. This is also j omega, but negative. omega. So this is, we already know the direction, so the direction is here. So our breakaway point is at s equals minus 1.69. so this is, if let's say this is 2 million, so here somewhere, okay, this is the S break. This point you call it S break, S break, okay. And this one we already know. This direction also we know. So this direction, if you want to show the direction, let's say I want to use it blue color for you to understand. This is the direction, okay, here, and this is the direction for this. Straight. This is the direction on this, okay, and this is the direction here to rest to infinity. Oh, where is this? Okay, this is the direction, and the direction is here. This is the breakaway points. Now we can check also what are the points. We know our asymptote will be at the -4, so that means here our asymptote is at a -4. That means S sigma, this is also you can write that sigma A, okay, this is also is at -4. Also, so at this point we have 3 angles, right? We know that at this point we have 3 angles: 60 degree, 180 degree, and 300 degree. You know from here, at this point we have 3 degrees. These are the 3 degrees, okay. Asymptote point is your -4, and we have these 3 degrees, okay, 60, 180 degree, and 300 degree. So if we go here now, go back to here now, if we go back to here, so in this point we need to draw the 3 angles. So how we can angle 60 degree, you need to we need to draw it, you need to measure and draw it 60 degree. So you can draw like this, maybe it is just an approximate. This is 60 degree, and 180 degree, actually 60 degree from here, so this is 60 degree, okay, this is 60 degree. So this is 60 degree, and this is your 60 degree, okay, not clear, 60 degree, or maybe I can write like this: theta 1 equals 60 equal 60 degree. But the next is 180 degree. So 180 degree means this one, this is the line. So you can actually also consider this line either like dot or anything. So this is line is 180 degree. This is theta 2. So you can consider like this: theta 2 equal 180 degree, okay. And then another one is 300 degree. So it is very obvious, 300 degree will be here. It's easy to draw, right? So this is 300 degree. So if you want to draw 300 degree, that means from here to here is 300 degree, theta 3. 300 degree. Okay, now understand. Okay, now we have the 2 points on the j omega axis. That one just we know from here. Just we calculated the last one. Breakaway point is done. This is already done. This is the one, the finding the j omega axis crossing. So we got 2 points, right? So plus j 5.66 and minus j 5.66. so it will be here. Let's say it is here and it is also here, example. So this is plus j 5.66, this is minus j 5.66. okay, so it's like this. So if it is like this, so what will happen? So this is our breakaway point. So in this case it will be like this, and also it will be like this. Okay, I try to do like a smooth drawing because here I cannot draw much, so it will actually go like this. Okay, so it's actually going like this. It is going like this. Come back to here. I show you the, so this is the figure. You can see this figure, then you will understand more. This is the figure you can see in your slide. You see how it's actually going. This is another example, but actually it is like this. It's from breakaway point, from breakaway points, it's a dividing. And so 2 different locations. It's like this. Okay, I think that's all. Yeah, I think that's all. Okay, so that's what we actually discussed. So if you see again, if you see the example again from the beginning, that we consider any function. This is actually antenna tracking system. From there we first of all you find the open loop transfer function. At the same time you write the characteristic equation, because characteristic equation equation, so you can write it, even you can calculate also. Even you can replace the value, of the 1 plus k into s plus 8, s plus 4. So you can even calculate actually what is the characteristic equation. Then you find the step, you find the each step 1 till the step I think 6, still 6. Then finally you do the sketching. Okay, that's all. Thank you so much.